So now Dr. Ola Zakaria will present us his work entitled Determination of Generalized Mathematical Model for Gear Monitoring. So Zakaria, you have 10 to 15 minutes to present us your work. Please, you can start.
Okay, thank you. Assalamu alaikum. Good morning, everyone. So today I will present my work entitled Determination of Generalized Mathematical Model for Gear Monitoring. So first of all, we start with the presentation outline, starting with an introduction about maintenance. Then see an introduction introducing the using experimental setup. Then the main objective of the perception test. After that, see how to find the generalized mathematical model for gearbox monitoring, and finally conclusion. As we all know that maintenance is an important element to ensure the proper function of industrial machine, to extend their lifespan in art domain, transportation, energy, fabrication, robotics, and so on. Now we need to have an overview of the factor leading to gear issues. The gear teeth can be deformed because the overload, heat, and fatigue. Also, it can be wear over the time because of the improper assembly. The corrosion is a common factor that can lead to gear defects. And finally, the gear tooth can be broke because the poor design. Now let's go to the experimental setup. This slide represents the test bench of the laboratory of mechanics sector at the University of Gelma, from which we took the measurement and selected the signal. Where we found that it's a little bit noisy. So this test bench is composed of electrical motor, two-stage gearbox, accelerometer, and per slab shop for data acquisition. For the 7 selected signal correspond to health gear, small defect on the gear 2, average and great defect on the same gear. The other, and we have the double defect on the gear 2 plus the gear 4. Now we see the same experimental setup was applied to the test bench of Laboratory of Vibration and Acoustic at University of Lyon, France. We take 7 measurement signal as the previous test bench. Now we can see a simulated defect on the gear. We have completed arranged the tooth and a half tooth broke. Now we go to the objective of the perception test. The machine vibration can be expressed through vibration indicators such as Curtis root mean square, energy, and so on. This vibration generates the noise, which can be measured directly with the microphone or by converting the vibration signal into sound, as in our case. So the main objective of the sound perception or this method is to find correlation between mechanical vibration and the generated sound. This part of chart represents the different steps involved in the perception method. This method was carried out under MATLAB environment. So first of all, we start with we select 7 signals, then convert them into sound. And calculate their scalar indicator. After that, we create 23 pair of sound using Ross series, starting from the 7 sound. After that, the 20 pair of sound represent to listener to start the test. And this phase we have two phases. The first one is called the learning phase. So the listener start to listen to the sound, to make them familiar with the seven sound. After that, in the second phase, it's based on the comparison pair in pair. It's based on the self-judgment of the auditor. In this test, we have 31 listeners was participant, 13 women and 18 men, aged between 22 and 50 years old. After that, a matrix of this symmetry obtained from the auditor judgment. Then finally, a multidimensional analysis was performed to get the perception space. The problem in this method that it's take time, because every listener make around 20 minutes. And because of the lack of volunteer, maybe sometimes it take 1 month, 2 months. So the objective of this work to find solution to these issues. For going now, as shown in this slide, the figure 3 presents the perception space of the sound corresponding to the different severity level of the gear fall. The listener, they make the order very well from small to great defect. Also, they are successfully distinct between simple defect and double defect. And for the sound one, it's assumed to be without defect, but after doing the envelope spectrum, we found it's correspond to shaft misalignment. This slide represents the result, the perception, the dispersion between the dimension D1 and the scalar indicator before removing the S1. We get a correlation coefficient equal to 0.9, and after removing the S1, because it's remained another type of defect, the coefficient, the correlation coefficient slightly improved to 0.94. Now the analysis of D1 value obtained by perception test and mathematical model confirmed the result found by Dr. Younes in his thesis, that the transition of the D1 value from negative to positive is synonym to transition of moderate from moderate to severe fault. Now, as I said before, the main objective of this work is to find a mathematical model that can apply it on every rotating machine. So in this I use Minitab 18 with the response surface methodology RSM. Based on the calculated scalar indicator and the result of the perception, the previous result of the perception test of the two test bench, the RMS and the LBA, we use the RMS in Minitab to develop a generalized model for the gear monitoring, eliminating the need to repeat the perception test for each rotating machine. As shown in the figure 9, the input is correspond to the scalar indicator, and the output is correspond to the result of the test perception. Now, the idea is the main idea is to combine the result, the scalar indicator of the test bench of Laboratory of Mechanics Structure and the Laboratory of Vibration Acoustic of in Lyon. we combined the scalar indicator as input and the result of the perception test as output, and also normalize the scalar indicator because they are different to each other. In the figure this that represent the Pareto chart that indicate three scalar and main the indicator, the scalar indicator that has highest percentage of contribution in our mathematical model. It showed our mathematical model. It's contribute with the energy and the root mean square and the peak value. Finally, we obtained our mathematical model based on the three scalar indicator and with the correlation coefficient equal to 91.91%. Now, to validate this mathematical model, we inject the scalar indicator of each test bench to the mathematical model to obtain the DIM1 for the laboratory, the first test bench, and the DIM1 for the second test bench. So the new value of DIM1. The figure 20 represents the new DIM1 value calculated from the generalized mathematical model. Has the 13 sound from without defect to double defect. We can see that the trend of value of DIM1 is respected. The only problem is at S5, and it's correspond to double defect. And as in the test of Professor Jbala Abdelazar, that because of the coincidence between the defect and also because the noise, because the test bench of the laboratory of mechanics structure has the signal was very noisy. So now we are going to the conclusion. In this conference, we developed a general mathematical model capable of being used for diagnosis gear fault, regardless of the machine or device on which the vibratory signal are measured. The model is based on the result obtained from the two sets conducted on the two distinct test bench. The most important result highlighted in this work is, on one hand, the validation of the result presented in the thesis of Dr. Yunus Ramadan, which show that the shift in DIM1 value from negative to positive is indicative of the transition from moderate to severe gear fault. On the other hand, it demonstrated that the removal of approximately 55% of the tooth model is still considered a moderate fault. Thank you for attention.
Thank you, Dr. Zakaria, for your clear presentation. So, if you have any question, please. Nordin.
So thank you for your presentation. Why did not think about the using of intelligence algorithm like TM, because I think with these tools you can increase the square of your model.
Can you repeat the question, please?
Why did not think about using the possibility to use
Intelligence.
intelligence algorithm like INN or SVN. Because I think with this you can increase the S1 of your model.
But without intelligent alternatives, I think it's 91%. It's enough to decide the health of our rotating machine. So why I need to increase my percent? 91 is enough. So maybe I will try to reject the intelligence alternatives.
Yeah, another question, please. So I think no question more. So thank you, Dr. Zakaria, for your presentation, and good luck for your work in the future. So the next one, please.